Hi guys, welcome to another episode of Gimazing Demos. And for this episode demonstrations, we will be demonstrating the different chemical reactions that will happen between sodium bicarbonate and vinegar and the catalytic reaction of the decomposition of hydrogen peroxide using yeast. And yes, we will be using those chemical reactions to ignite and extinguish a flame. So what are we waiting for? Let's do this! For today's experiment, I'll be demonstrating to you the flame light relight experiment using these materials. Hydrogen peroxide, acetic acid, baking soda, yeast, and our flame source, which is our matchstick. And two separate containers contain our solvent. First, our acetic acid. Secondly, in a separate container, contain our hydrogen peroxide. Taking consideration also the amount of solvent in each container. In this case, we put 50 ml of our solvent in each containers. After securing, add baking soda to our vinegar. As soon as our baking soda is added in the vinegar, a chemical reaction happens. The formation of bubbles, also known as effervescence, occurred. Therefore, this chemical reaction of acetic acid and sodium bicarbonate is a fast reaction. On the other hand, we are adding yeast to our hydrogen peroxide. In this case, I am adding 2 teaspoons of yeast to our 50 ml of hydrogen peroxide. The catalytic reaction of the decomposition of hydrogen peroxide in this case has a slow pace. Therefore, this reaction is a slow reaction. Using match as our primary source of heat, we will going to test how this chemical reaction ignite and extinguish flame. In the first case, the decomposition reaction of hydrogen peroxide produces oxygen molecules, which makes flame to be ignited. On the other hand, the case of sodium bicarbonate added to vinegar produces carbon dioxide, which causes the flame, when subjected to the chemical reaction, to be extinguished. As a weak acid, acetic acid is a substance primarily containing 2 carbon, 4 hydrogen, and 2 oxygen atoms, while sodium bicarbonate can be represented as NaHCO3. The chemical reaction of these two substances can be classified as a double displacement reaction. In the reaction, the two substances dissociate into its constituent ions and binds with one another, resulting to a product of carbonic acid and sodium acetate. However, carbonic acid can be easily dissociate into water and carbon dioxide in normal conditions. Therefore, sodium acetate, water, and carbon dioxide are the products of this reaction. In the catalytic reaction between hydrogen peroxide and yeast, yeast acts as a catalyst to the decomposition of hydrogen peroxide. It contains a special chemical known as catalase present in almost all living things that breaks down the bond of hydrogen peroxide. Hydrogen peroxide then decomposes into water and oxygen. As a catalyst, catalase decomposes hydrogen peroxide. Thus, energy is released, making this reaction an exothermic reaction, while yeast maintains its chemical composition. Thus, for this reaction, water and oxygen are the products. In relation with the ignition and extinguishing of flame, the gaseous products of two reactions hold the science behind the experiment. In the decomposition of hydrogen peroxide, oxygen is produced. As one of the 3 factors in fire triangle, the presence of oxygen fuels flame. Thus, as in the experiment, when a small heat source is subjected to the bubbles produced by the decomposition of hydrogen peroxide, a flame suddenly is observed. Therefore, what is inside the bubbles produced by the reaction is oxygen. However, this was not the case for the reaction of sodium bicarbonate and vinegar. As soon as the flame is placed to its reaction, it extinguishes, therefore establishing the absence of one of the components of the fire triangle. When sodium bicarbonate and acetic acid are mixed together, it produces carbonic acid. Carbonic acid is very unstable and further decomposes to water and carbon dioxide. That is why bubbles can be observed in the reaction. Those bubbles are carbon dioxide. The lack of oxygen in the container extinguishes the flame. Therefore, oxygen ignites flame while carbon dioxide extinguishes flame.